Okay, we are moving on to surface area of pyramids and cones. So we'll start with pyramids because finding the surface area of the pyramid is the same as finding the surface area of a prism. It is the sum of the area of all the faces. So in this particular picture here, we have a square, probably, but at least a rectangular base. And then we have 4 triangles. So you would find the area of each of those and add them together. Let's jump right into an example. We have a square pyramid. I know it's a square pyramid because the base, which is the face across from the point, is a square. And it is a 6 by 6 square. So that's how we would find the area. And then we have 4 identical triangular faces. And each of those triangles, if I draw one down here, has a base of 6 and a height of 8.5. So for all 4 of those triangles, we're going to do half of the base times the height. It'll be the same for all of them. So let's go through and do my calculations. 6 times 6 is 36. And then we have 0.5 times 6 times 8.5, which gives me 25.5. And all 4 of those triangles are exactly the same because they have the same measurements. So my final step is to add up these 5 areas. So I'm going to do 25.5 times 4, and then I'm going to add 36. And I get 138 meters squared. All right, then I have another square pyramid over here, and it has a base that's 12 by 12. So we're going to do 144 for that one. And it also has 4 equal sides, so that are triangles. And one of those would be half of 12 times 9. You would do that, and then you would add them all together. I'm going to be, well, I might as well do it. So each of these is 54. And let's get an answer, 54 times 4. And then we'll add 144. So this one would be 360 yards squared. All right, let's do a pyramid that has a triangular base instead of a rectangular base. So this has a triangle as the base. I know this is my base because it is across from the point, right? And then there's something else we need to notice here, and that is these marks. Do you see these little marks right here? These all mean congruent, which means that that's an equilateral triangle, or that all the sides of that triangle are the same. So my base is a triangle that has 11 on each side, and the height is shown right here of 9.5. So for the triangular base, it's half of 11, which is the base, times 9.5, which is the height. So I'm going to do 0.5 times 11 times 9.5 for the area of that base triangle. Now I have 3 other faces that are triangles. In my previous examples, I had 4 faces around the sides that were triangles, but this one only has 3 because they're each coming out of one of the sides of that base, and the base is a triangle, so there's only 3 sides that can have a triangle coming out of it, right? So each of these 3 triangles is 1/2 of 11, because they're all 11 on the bottom, right? And then the height of one of those sides is 10.5. And these will all be the same. I'm just doing an arrow to save space and time. So each of those triangles, putting it into my calculator now, is 57.75. That's a 7. So let's write that out 3 times because each triangle is the same. To add them up, I'll multiply 57.75 times 3, and then I'm going to add 52.25. And I get 225.5 inches squared. Okay. Then we have another triangular prism that I'm going to let you do. But if you count up, actually, let's do that one together, just so we've covered all of our bases. Here's my base, right? You could really call any of those triangles the base because all of the triangles are across from some point in that figure. But for that one, we have half of the base, which is 20, times the height, which is also 20. And then the triangles around the side are not, oh no, sorry. I'm glad I didn't go too far here. The height is not 20. I think that this number right here is what's pointing to this line, correct? Yes. So that's 17.4. Okay. Now we have three different triangles. We have this one, and we have this one, which are the same because they have this same base of 20. So we have two around the sides that are the same, and they are half of 20 times 17. Oh, they're all the same. Because look, this is also 20. All right, well, I thought that I was going to give you an example where the triangles were not all the same around the side. Sometimes they're not, but okay, this would be half of 20 is 10, so these are 170. I was trying to save time, but it's okay. Who doesn't love doing one more math problem? Oh, this is 10 times 17.4. So we have 170 times 3 plus 174. 684 feet squared. Okay, now let's get into the surface area of a cone. Now, the surface area of a cone, I've been really trying to have you think about these logically and not memorize formulas. However, we will need to use a formula that we memorize for surface area of a cone. And here it is. It's, well, first of all, this part you will know that it's the area of the circle, right? Because we're adding the area of all the faces. So it's going to be pi r squared for that circle. And then we're going to add the area of this part of the cone, which really isn't a shape that we would recognize, but it is going to be pi times the radius of the circle times L. And the L stands for the slant height. So you might be thinking, oh my goodness, I've never seen that before. What on earth is that? The slant height is this measurement from the point to the edge of the circle, which is different than the height, which is this. So this would be the height. This would be the slant height. This is going to be our radius. So we're going to use that formula that we are going to memorize to do this. The surface area of a cone is the area of the circular base, which is pi r squared, plus pi times radius times slant height. Here's my slant height. My radius is 4. So let's just fill that in then. We have pi times radius squared plus pi times radius times slant height. In my calculator, then, I'm going to be doing 3.14 times 4 times 4, or times 16. And then separately, because I add last using the order of operations, I'm going to do 3.14 times 4 times 11.7. And I get this, and then I'm going to add them together. Doing it in my calculator, but always showing my work. You'd have to write stuff down anyways. There's no way you could keep track of all this in your head. All right, and then this cone over here is the same thing. It's going to be pi r squared plus pi r L, so 3.14. Oh, it's another example of where there's something missing. And so I will give this, well, I can tell you exactly what it is because what they want us to do is use the Pythagorean theorem, but we haven't learned that yet. So, but I do want to make it exact. So on my calculator, I'm going to use the Pythagorean theorem. And even though you haven't learned it yet, I'm going to use it to get the correct. And then, oh, this doesn't have a square root. Yes, it does. I turn my calculator to the side. No? Scientific. Where's the square root button on this iPhone? Okay, well, I don't know. Let's just make it like, let's make the radius 10. Let's make our life easy. So 10 squared plus 3.14 times 10 times, this is the slant height, not the 16.8. And then you would multiply this out, and add them together. So I will need to go back to the notes and add a radius of 10 to that problem.